Good afternoon, everyone, and welcome to the Construct Innovate webinar series on modern methods of construction. My name is Jamie Goggins, and I'm co-director of Construct Innovate, which is Ireland's National Research Centre for Construction Technology Innovation. We're running this webinar in association with Engineers Ireland. It's an 8-week series, and this week the focus is going to be on steel solutions. This is the fourth webinar in the series. We're going to focus on steel solutions and unlocking modern methods of construction for smarter building delivery. With three great speakers again today. So we've from different perspectives. So our first speaker is Paddy Mahon, who's the head of design and engineering at Framespace, and he's going to talk about it from the manufacturing perspective. So transforming construction, use of light gauge steel modular systems for smarter and greener building solutions. And to help to achieve, I suppose, these greener solutions and to make sure that we can have energy efficient buildings, Dara McGowan, director of Partel, is going to talk to us about membranes and the use of membranes in MMC to achieve these low energy buildings. Then we're going to get it from the contractor's perspective. So John O'Connell from OCC Construction, he's a senior contracts manager there, and he's going to focus on unlocking modern methods construction, and from the contractor's perspective, why they're embracing the use of modern methods construction. The focus, obviously, this week on steel solutions. So without further ado, I'm going to hand over to our first speaker. So first speaker being Paddy Mahon, who's head of design and engineering at Framespace, and he's going to bring us through it from the manufacturing perspective. So over to you, Paddy.
Hi everyone, my name is Paddy Mahon. I'm head of design and engineering at Framespace Solutions. This presentation title is Light Gauge Steel Modular Solutions for Smarter and Greener Building Solutions. So what we plan on covering is a brief introduction, just touch on design, run through of the testing and analysis that just demonstrates compliance for the systems, look at a case study we did on embodied carbon, system certification, collaborations, and some interesting sample projects. So a bit about Framespace. It was set up in 2016. We're based in Longford Town in Ireland. We specialise in design and manufacture of light gauge steel building systems for the residential and commercial sectors in Ireland in 2D and 3D solutions. Our two main offerings are 2D panelised system category 2, a closed panel system assembled in the factory with different levels of finishes, and that's installed as panels on site and then fitted out on site. We also do 3D volumetrics, so category 1 modules providing a minimum weather tight structure, and trying to complete as much of the fit out off site as we can. So just to go through the differences between the 2D panel and the 3D volumetric systems. The 2D closed panel, you can see a panel on the left being installed on site as the window and brick slip fitted off site. So typically they'd have a pre-manufactured value of about 30 to 40%. The panels are installed on site and then the fit out is completed on site. It's fairly flexible solution, so it can be made align with most layouts. It has a good level of cost and program certainty, but the fit out is still completed on site. The 3D has a pre-manufactured value of typically plus 90%, fit out completed off site, but early engagement and consideration is important if you're going to be using a volumetric solution on site. The layouts need to align with that in terms of floor and wall build-ups. It has a very high level of cost and program certainty, with the civil substructure, the only site activities being completed on site, as well as tying in between the modules. Just a bit about our design and build workflow. So we have a common data environment. We use Autodesk Construction Cloud for design coordination and for the site aspects, and then we use a factory control system called Workflow. So the two of those are linked, and all our design is, say, we take a design, we model it architecturally from a steel perspective and from M&E coordinated, and then the output is in terms of 2D panels, simplifying it from a manufacturing and an install perspective. Looking at testing and analysis that's carried out in the system to demonstrate compliance and performance. So structure part A, which will be completed on all jobs, is completed by a chartered structural engineer. So there's a full structural package done in terms of structural models and calculation pack, and then that all gets input into like steel and hot rolled steel models, and is coordinated through, say, Vertex and Tekla. Part B, fire. So we have a full suite of loaded fire tests in our system: external walls, compartment floors, and load-bearing internal walls, covering 30, 60, and 90-minute fire resistance. On the left, you can see an unexposed side of a fire test panel with the thermocouples and the gauges and different things on the outside. And on the bottom left, you can see the inside of the furnace during one of our fire tests. CWCT testing. So we carried out a full-scale test. It's probably a year and a half ago now. So it's a very onerous weather test, testing the air permeability, the weather resistance, which you can see in the video on the left. It's like a jet engine forcing spray water at the face of the wall while there's a vacuum inside, testing the wind resistance. And after all those tests, there's a hard and soft body impact test to see how it performs. Hygrothermal testing. So we've tested a wall panel in a hygrothermal chamber, and basically that runs a series of heat rain cycles and freeze thaw cycles, and then there's a bond strength test and impact test carried out on the panels after all them cycles are ran to see that how it performs, if it still maintains those bond strength and impact tests or impact performance. Acoustic testing, again, this would be a regulatory requirement anyway. I suppose during the system development, we would have done a suite of acoustic lab tests to try and refine what works in terms of boarding and insulation. And now we have a full suite of site testing carried out so they can carry out further analysis. Just aside. Fabric performance. So we have a full suite of thermal models complete on 2D and 3D junctions. We have hygrothermal analysis carried out on floor, wall, and roof buildups, and we'd be typically achieving an air tightness of between 2 and 3 meters cubed per hour per meter squared. Just a bit on an embodied carbon study that we carried out. So we carried out an embodied carbon study on some 3D modular houses. So this was the initial findings prior to running optimizations and things like that. So what was interesting here was that when we look at the different stages of the life cycle assessment, A1 to A3 was really significant in terms of the contribution of embodied carbon coming in at 69%. So that was an obvious place for us to start in terms of looking at optimizations. So as part of that, we compared it, the same house type for traditional blockwork, traditional timber frame, the current state modular build-up we had, and then looked at what we could do with different materials and different designs to try and optimize where we could go. And what was really interesting about that was you can see from the fourth bar over, when we looked at a different supplier of the light gauge steel, a greener steel, it showed a huge drop in the embodied carbon, and that was just one alteration to a product. So that's all to do with the mill where it's produced, the electric arc furnace, recycled steel input, and I suppose on-site renewables to offset against the energy that's used to produce the steel. So it's just a really interesting study. The optimized modular solution is on the very right at 386. So that came in below the blockwork and the timber frame, but that doesn't consider sequestered embodied carbon. So on the bottom bar in the green, you can see the sequestered. This timber frame comes in quite low, but the modular solution is still very competitive. Certification. So we have our CE in 1090. We have an NSCI Agreement cert for our LGS system to construct buildings up to 20 meters to the top floor. We have UL certification for our external wall buildup, and we have ISO 9001. Just some collaborations we have. So we're a member of Construct Innovate, and we were awarded 2 Construct Innovate Seed Fund projects back in September. So we're working with University of Galway on those. They're ongoing at the moment. So one of them is around reducing embodied carbon in the manufacture of light gauge steel modular construction. So that touches on what the study we had done previously around alternative materials, and then just analysing what types of buildings and the layouts of buildings that work best from an embodied carbon perspective. The second study we're doing is an optimizing slot and stud panel connector for light gauge steel frame systems. So that's looking at more efficient ways of connecting the 2D system on site, trying to speed up the process and get a stronger connection as well if we can. So some interesting case study projects. So you have the Ukrainian modular housings project, and there was 166 units completed as part of that. The client was Cisco and the OPW. You can see an image there of some of the finished single-story units that we completed. The images here show some of the internal finishes. The central picture shows the modules being lifted into position, and then the other images are just showing the external finishes as part of that. As part of that same project, we completed 6 2-story, 3-bedroom houses. Each house was comprised of 4 modules, so there was that interconnection between modules that we had to complete on site. But again, the majority of the finishes were completed off site. So really proud of that one, and it came out very well when it was all tied in and finished on site. This is the KCR project. So this is 15 apartments completion in Dublin in 2D. So you can see the level of finish that is on the 2D panels going to site, and you can see party walls there, the inside of the external walls, and there was actually bathroom pods in that project as well. Again, you can see top right was that panel on the ground floor being lifted in. The other two floors on the left are work in progress, and the bottom right was the finished product. This project is the Kilcullen Riverside Manor project, or Riverside Manor, Riverside Green. So phase 3 of that project is currently ongoing. Phase 2 completed last year. It's 180 units in total, including housing, apartments, and duplex units. So we're working as a main contractor there. It's a turnkey job for us. It's going to site as 2D, and we're well underway in phase 3 there. So you can see some images of phase 2 completed around the perimeter. The top right is volumetric roof sections being lifted in. So that allows us to weather the houses quite quickly in a matter of days, and the external finishes can proceed while the internal fit out is progressing inside at the same time. Another really interesting project was Drumhearney Woods Holiday Village. So this was 16 chalets completed down in Leitrim Village. The client had a very specific requirement here that they didn't want to pour concrete into the forest environment, and they wanted to minimize the amount of trees they would cut down or remove local to where the units were going. So there was no real room for scaffolds, so we had to come up with a solution that all the external panels would be predominantly finished externally, and we came up with a screw pile solution with Screw Pile Ireland. So these units are stood on screws off the forest floor, with the floor panel sitting on top of that, and then the buildings were formed above that. So they nestle really nicely into the forest environment. You can see the top left there is one of the triangular units that were completed there. So it's one we're really proud of. It's really unique in the way it looks. The central picture shows the wall build-up, so you can see the Seadrill cladding on the outside and Partel's Experm 150 breather membrane as part of the build-up as well. The other images show the triangular units nestled into the forest landscape. And one final case study, it's a project we're working on at the minute. I know John might touch on it as well with OCC. It's the Mount Lucas LOETB modern or MMC demonstration park. So Leash Offaly Education Training Board are creating are building an MMC demonstration park, and we're completing one bed and 1 3-bed modular houses. And the unique thing about these also are that they're ZEB units, so they have enough renewables on or in the units to offset against the energy consumption. So that's a really unique and a unique performance criteria, and it's one we're really excited about being part of. That's it. So it was a big presentation, ran through very quickly. I just want to say thanks to Jamie for having me in Construct Innovation Engineers Ireland, and I'll take any questions at the end. Thanks.
Brilliant. Thanks a lot, Paddy. Fantastic how you've fit in there to the 15 minutes. Great to see, you know, the range of testing, but also the design requirements in there, and then to showcase some of the projects that you've been involved in. So now we'll move over to Dara. You already got a little plug there from Paddy in terms of one of the Partel membranes into their system. But Dara is going to go through, so Dara McGowan, who's director of Partel, is going to go through the use of membranes in modern domestic construction in there to help in terms of the air tightness and weathering. So over to you, Dara.
A little red pointer here on the screen as well, just in case I'm pointing anything out, so everyone at home can keep an eye out for the red dot here. So thanks, Jamie, for having me. So I'm going to focus on membranes, and as Jamie said, I got a plug from Paddy and Framespace there. So in Partel, we'd specialize in, I suppose, manufacturing and supplying the membranes into the likes of Framespace and Green Frame and different metal frame manufacturers across Ireland, I guess. So we do a lot of things in Partel, but that's the primary role for today's presentation, I suppose. So we were established in Ireland. I'm based here in Galway, but we're active in lots of different markets, including Ireland, the UK, North America, Canada, Europe. So it's kind of interesting to see how different markets approach MMC. I can say for sure that we are doing a great job in the Irish market, and there's lots of markets actually looking at how we're doing it and trying to replicate that. So I'd be happy to chat about that during the Q&A as well. I move around from country to country quite a bit. Again, I won't bore you with too much detail. I want to jump straight into the presentation, but the main, I suppose, role that we play in supporting the likes of Paddy and John is manufacturing and supplying membranes, both breather membranes and vapor control layers, into MMC companies, so people who are manufacturing out of steel or timber. And I want to get into, you know, how we can help in that sense today. I wanted to take a slightly different angle on the presentation to what you might be used to. You know, we're known for our air tightness detailing and things like that, but we're already doing quite a good job of that in the Irish market. So I wanted to get into a little bit more detail. So this presentation definitely gets into more of the technical performance on the products. But just before I do that, I suppose generally there's 4 reasons we want to build an airtight structure. It's to lower energy costs, it can help improve comfort levels, it can help improve indoor air quality, and it can also help with structural integrity, particularly where you're using timber studs or OSB sheeting or something like that. But in today's presentation, I want to really drill into the lowering the energy cost side of things. So as we make a building more airtight, its energy performance can improve. What you're looking at on the slide here is basically a house that I modeled in DEEP, which is the energy assessment tool used to create your BEO rating for anyone that's not familiar with that. DEEP is the Dwelling Energy Assessment Procedure, and that house was designed to the NZEB standard, which is our current standard here in Ireland, to achieve Partel compliance. But all I've done in this slide here is change the air permeability. So everything stays the same, bar the air tightness value, coming from worst case scenario for Irish compliance since 2019, which is 5 meters cubed per hour per meter squared, all the way down to 0.6, which is passive levels of air tightness. So you can see that the energy value, or the value used to maintain a comfortable internal climate in that project, is reducing all the time as we get more and more airtight. So that's the first way that your airtight products can help with energy efficiency. You're retaining heat much more efficiently. We're kind of used to how to do that, to be honest. So we'd have our standard vapor control layers, which is Isoperm Plus. We have high performance airtight tapes like Conexo, and we have quality breather membranes like Exoperm 250 SA. I've seen some of that on Paddy's presentation as well on some of the housing estates. They'd all be Passive House certified. The products are really good. The knowledge is out there with the training centres available in Ireland. We have a great support system that was set up in 2019 through the NZEB Centres of Excellence. So we're doing really well with achieving good air tightness results across the board. When it comes to MMC, builds, it can get a little bit more complex in that our membranes can actually start working a little bit harder for us to improve the energy efficiency in some other ways. So rather than looking at the overall energy efficiency, we can use certain types of membrane to improve our U-value performance as well. So for example, Partel Ecofoil Exo and Ecofoil ISO are reflective membranes. So that's what they look like. They're kind of a shiny finish on the outside. If you've driven past, 80% of development projects in Ireland, you probably see a reflective membrane on the outside, and you might wonder, why is that used instead of a normal breather membrane? The reason for that is because it's shiny, it has an enhanced emissivity. And what that means is that foil can actually reflect heat back into an airspace, and as a result, it can improve our U-value calculation. I'll show you an example of it in just a second. There's two ways that can be calculated. So we either rely on the emissivity value that we have to test as part of our DOP standard. So we basically determine how shiny is that foil, and that gives us the emissivity value of 0.05 in our case. Or we can put it through a hot box test, which is, a physical test done by a notified lab. They put a heat source on one side of the membrane and they measure how much heat it's retaining. And that again is impacted by how shiny the foil is. And that can give us an OR value of 0.78. Anyone on the call who is used to doing U-value calculations, you'll know that the OR value is what we need to work out a U-value. I'll show you how that's included in just a second. One point to note, if you do want to benefit from the use of foil membranes, they have to be beside an airspace. So if you have an insulation over this, or you have a board over it or something like that, the foil value is no longer there. So these have to be used beside an airspace. So just to show you a very simple example, my slides are definitely less impressive than Paddy's, but here we go. If we look at a standard build-up, this could be timber or metal frame. If we have a plasterboard on the inside, a service cavity, which is quite common, and actually required in this case if you want your membrane to perform correctly. Then we'll have our insulated stud. That could be a metal frame or a timber frame stud. Either will work. It could be a cement board or an OSB board on the outside. Then we'll have a ventilated cavity, and we might have an external brick, block, cladding. It doesn't really matter. If we apply two foil membranes like Partel Ecofoil ISO vapor control layer on the inside and Partel Ecofoil Exo breather membrane on the outside, that is going to enhance our U-value performance. Just again, take note here, this red line is beside an airspace and the blue line is also beside an airspace. That's quite important. And this is what the U-value looks like. I use the BRE U-value calculation tool. And you can see that the foil has enhanced our airspace in the service cavity from 0.18 to 0.78. And on the outside, it's enhanced our performance to 0.67. That mightn't be relevant for everyone on the call if you're not doing U-value calculations, but ultimately what that means is if we use reflective membranes in this particular build-up, this one is a timber stud actually rather than metal, but the same principle applies. We have a U-value of 0.18 in this case. If we were to just use standard VCLs and breather membranes, that would push the U-value up to 0.22. So it's the exact same build-up, but we've changed to a non-reflective membrane on both sides. It can impact the U-value in quite a significant way. We would also do lots of work with, again, with the likes of Framespace and Green Frame and people like that, our offsite customers, around condensation risk analysis. And to do that, we use a software called Woofy. Paddy mentioned hygrothermal testing and things like that, which is really interesting. But we would do lots of that on the design side. So we would test systems to make sure that they don't have a risk of interstitial condensation or mold before they get constructed. To do that, we basically use materials from a Woofy database, which are available through the Woofy software. And we can take a whole wall buildup or a roof buildup, for example. We can put in air leakage, ventilation rates, location, driving rain, all of those sorts of impacts, and see if it has any risk of condensation or mold. This is an example of the green frame wall buildup result. So you can see here that the moisture content is very low. These peaks and valleys, by the way, are normal. That's just winter, summer drying. So we'd expect those peaks and valleys. But the key thing here is that the peaks are not getting any higher, which means we've reached a state of equilibrium, and they're well below a risk point of about 12% moisture content. So we're fine with that. There's no risk in the fiber cement board location. Same in the rock wool, there's no risk there. And same in the Cineate weather defense board, which is on the outside of the system. If I just go back a slide or two, that's in this location here. I suppose it's a very short presentation to try and outline how Woofy works, but I suppose the summary of what it does is it just gives our customers peace of mind that from a moisture management perspective, the wall or roof is safe and it's not going to trap any moisture. We can also look at relative humidities, which is the green line in this case here. Again, it goes up and down depending on the time of year, but we're just making sure it's not exceeding that 80% threshold where you might get a risk of mold in your buildup or even condensation if you go above that 100%. So again, it's just peace of mind for customers. So my presentation, I wanted to keep it pretty short. I guess we do have two Engineers Ireland approved CPDs that can get into a bit more detail on this type of thing, which in summary, we support our offsite customers by supplying membranes, some of which keep the building safe from a moisture perspective. Others do that and also improve the U-value calculation as well. So that's it for me. I'll pass you back to Jamie.
Brilliant. Thanks, Dara. I'm sure there's going to be lots of questions there around membranes, the use of membranes within buildings in there. So without further ado, I'm going to pass over to John. So if you have any questions for Dara or indeed Paddy, then please put them in the Q&A function there. So we'll pass over to John O'Connell now, who's Senior Contracts Manager with OCC, and he's going to give us unlocking monumental construction from the contractor's perspective. So over to you, John.
So today I'm just going to give a brief run through of modern method construction and hone in on light gauge steel with OCC construction. So I'm just going to run through our progress to date, current strategies employed, and our run through of current case studies on hand, and our challenges and learnings. So initially back in probably 2021, we realized that traditional building wasn't working for OCC. There was a lack of skilled labor to carry out wet trades and block laying and so on. And every project was running behind schedule. So this led to the formation of Green Frame, a sister company of OCC Construction, and our own light gauge steel NACI certified product. So that was improving the materials we used to build the buildings, and then we looked at our design process improvement. So getting engagement from every member design team and the contractors team in collaborating at an early stage to make improvements to designs on when it's easy to do so on a BIM model rather than retrospectively on site. And the next stage of our progress then is delivery process improvement. So this is taking the benefits of your lean manufacture on your factory floor. So when you're constructing your house on factory floor, it's very easy to achieve high efficiencies across the board, and replicating this then when you come to site, everything goes together as planned, like a jigsaw puzzle, and there's no issues on site. And this leads on to the fifth step, which is sustainability improvements. That's taking the whole system as a whole, or the whole construction methodology as a whole, and refining everything to ensure we're maximizing every resource that goes into each of the projects. So current strategies employed, majority of our sites now are light gauge steel sites. So we're using a 2D panelized light gauge steel system, which also uses Partel membranes, similar to what Paddy is using in Framespace also. So this is primarily used for duplexes, houses, and apartment blocks. So we're combining the light gauge steel with poured in situ concrete decks. So this does aid with your fire compliance and achieving overall compliance in the structures. And operational wise then, to minimize the amount of trades, really coordinating with your light gauge steel system. Internally, we're opting for electric heating systems and combining these with PV panel installations. And as a construction is carried out on site, we're rolling out our lean construction last planner system, which replicates your factory floor to the day-to-day elements of your construction site. So why use modern methods of construction and specifically like edge steel? So cost control. As we have the design team, the contractor, and a lot of your subcontractors collaborating at such an early stage, a lot of the issues that present themselves on a construction site are ironed out. So taking M&E for an example, all the service runs will be in place for your plumbing, for your electrician when they're on site. So it removes the need for them to be drilling any holes. In a perfect scenario, everything just goes together and there's no drilling through or chasing walls and so on. It's all planned out and thought of ahead of time. Regarding speed, from what we're building on, it's probably 5 or 6 live like steel sites at the minute, we're achieving overall program savings of 20% in comparison to traditionally built such as blockwork buildings. Regarding quality testing and certification, because we're nearly going through the BCAR process at an early stage before the model goes into production, a lot of the issues you may face later on in the project are dealt with, and any products can be easily swapped out when you're looking at a BIM model rather than on site. Regarding health and safety, so there's a massive reduction in the number of trades that are working in close proximity to each other. So ultimately, you have a safer site, you have fewer men on site or operatives on site, and that does result in a lot less health and safety incidents, and it makes for a lot cleaner, tidier site overall for all involved. Regarding sustainability, because a lot of the products are manufactured within a factory controlled environment, from our analysis, we're saving about 15% of materials, whether it be insulation or membranes and so on, when they're cut to order off-site and brought on site as they're required. And the biggest one for us is project risk avoidance. So by ensuring everyone has their thoughts incorporated into design before it goes into production, it really does take away the risks that you can run into on site with unexplainable delays. So I just to give you a run through, put a simple table together there showing where we do have what our methods of construction time savings on site for a contractor. So regarding with respect to risks, labour, weather, safety and design, I've kind of gone through already. And the certification and handover, a lot of the certification and handover documents are completed at an early stage when you're going into production rather than a later stage in your project. So a lot of the issues are already been dealt with, which does give you that buffer at the end of the project where you do achieve significant time savings. So just going to give you a run through of a Galway case study. So it's a 102 unit like a steel development. So calling this day 0. So it's pouring the raft. That was probably last December. Then 10 weeks later, so you have 2 blocks of apartments here. You have 22 apartments and 33 apartments. And the rest of the site has taken formation as it goes. So typically it's taken 2 weeks of lift to jump a floor plate on site with the Leica steel. That's putting up your steel, pouring the concrete decks and jumping onto the next floor. So when you compare this to traditional blockwork and pour in situ concrete frame, there is significant savings overall, and probably more than 20% when you look at it in finer detail of getting your initial structure up. So taking the same site 24 weeks ahead of the last update, as you can see, there's been a lot of progress. The first block is nearing completion, ready for handover. And this is facilitated by the fact that you can finish floors while you're still building the structure. So once you're 3 floors higher than the floor you're on, we're typically fitting out that floor. And it did mean that a lot of the internal trades got a head start on program and ensured a lot of efficiencies were achieved. So just run through the challenges and learnings. So design for manufacturer assembly philosophy. What we're seeing in a lot of sites is a project is going through the full plan process, it's handed over to the contractor, and there's no real collaboration or no input from the contractor before it's too late. So I think there is, across the industry, there is definitely a greater need for design for manufacturer assembly philosophy, and there's be a lot of efficiencies to be gained from it, whether it being making the size of your overall building dimensions down to panelized sections or so on. There is definitely a lot of improvements we can make if design teams and contractors can collaborate at an early stage in the project. Number two, regarding design freeze. So typically we're achieving design freeze the day before we're going into manufacture with, say, like a steel manufactured panels. We're finding for every day that we delay the design freeze to make sure we've taken into account everyone's comments, that we're saving 4 days on site regarding trying to make them changes on site. It's very easy to move a wall on a BIM model, but it's very hard to move a wall on site. Continuity and repetition. There is a greater need for both contract design teams to use the same building types over and over again. So just when you look at it over on a whole, like the whole design stage process, how long it takes, how many man hours it takes, and different contributors, when you have a finished design, it would be very beneficial for all involved to be able to replicate it. So when we're looking over the past year, across 5 to 6 live projects, we're looking at only 3 to 4 buildings that were replicated, and that's across housing estates and so on. I think there is great improvements to be made in this for the industry at the minute. And regarding education, so we invested a lot into educating the full site team. So down to a site operative that's cleaning out units up to senior management, everyone has a great understanding of modern methods of construction, lean construction, and understands every part of the process. So whether they're building a hole or whether they're drilling a hole through your external envelope, they fully realize that the knock-on effect they may have in their tightness further down the road. And Paddy mentioned earlier about the modern methods of construction campus in Mount Lucas. So we're also contributing to this project. We'll be constructing 5 units. 3 of these will be like a steel. There'll also be a printed 3D volumetric concrete, and there'll be an ICF unit as well. So this is carried out in collaboration with the Offaly Education Training Board, the Irish Green Building Council, Construction Innovate, and the Passive House Association of Ireland. And just give a run through of what we will be demonstrating as part of the park. So the first unit, you've got a 3-bedroom duplex unit with a concrete deck. So that'll be 2D panelized light gauge steel. The second unit will be designed to replicate an infill development. So this will be volumetric 3D light gauge steel, which will be dropped into place when both these units are in place to replicate an infill development within a city centre scenario. And the third unit will be printed 3D concrete, and down here it's a block of semis. So we're taking the opportunity to use the block of semis as a sustainability study. So we'll be looking at the embodied energy, embodied carbon of both the light gauge steel and the insulated concrete formwork, and carrying out analysis of how we can make improvements to our residential housing stock. And we are also on the lookout for collaborators. If you'd like to get involved in the modern methods of construction campus in Mount Lucas, feel free to drop me an email. that's all from me. And thanks very much to Jamie and everyone in Construct Innovate for the opportunity today. Welcome any questions you may have.
Brilliant. Thanks, John. Thanks for a great run through showcasing, I suppose, from the contractor's perspective and some of the drivers around why a contractor would embrace modern methods of construction and some of the advantages that you've seen within your organization. And I suppose some of the challenges and opportunities there as well.